In this video, we'll continue to review single component systems. The objective will be analyze and solve single component systems. Recall the 5-step approach. Think about the problem, try to understand the problem, describe the problem mathematically, solve the equilibrium equations, learn from the solution. Let's look at the questions we're going to solve today. Find the total moment about Q produced by the forces, pressures that act on the retaining wall shown below. Assume the wall is 1 meter long into the page dimension. The forces consist of two components, a UDL, which stands for Uniform Distributed Load on the horizontal leg, and a triangular load on its vertical. We're going to find the value of the horizontal and vertical point loads, the moment generated by the horizontal pressure and by the vertical pressure about point Q, and will this wall overturn? Feel free to pause the video and solve it on your own. Firstly, we're going to look at the vertical component. The point load will be 45 kilopascal times the length of the leg, 1 meter, times 1 meter. As the question is given, the retaining wall is 1 meter long, the into page dimension, which we will get 45 kilonewtons. Vertical point load is acting downward, which provides a clockwise moment. Therefore, the moment about point Q due to the vertical point load will be a negative 45 kilonewtons times the distance, 1/2 times 1 meter, which we will get a negative 22.5 kilonewton meter counterclockwise. This is negative only when it's counterclockwise. We can also write it as 22.5 kilonewton meter clockwise. Next, we're going to look at the horizontal component. The horizontal point load will be 10 kilopascal times 1/2, since this is a triangular load, times the length, 2.1 meters, and the into page length, 1 meter. We will get 10.5 kilonewtons. And for the moment, the horizontal point load will provide a counterclockwise moment about point Q. Therefore, the moment created by horizontal component will be positive 10.5 kilonewtons times the distance. Since this is a triangle, the distance will be 1/3 of its length, 1/3 times 2.1 meters. We will get 7.35 kilonewton meters counterclockwise. Lastly, we need to check if the retaining wall overturns. The determined criteria will be if the absolute value of moment about point Q created by vertical pressure is larger than the horizontal pressure. The retaining wall won't overturn, vice versa, and in this problem, the vertical one is larger than the horizontal one. Therefore, this wall won't overturn. And in summary, here are the answers for the problem. That's it for the video.